Okay, so this is where we left off. So we'll continue in our script. So first things first, we'll add a new variable here, one that's going to help us out with the actual jumping. So first of all, we'll just create the, let me first create the variable. So this is going to be the delta position, a vec3 value, okay, so initialize it to 0. Okay, so initialize it to 0. So this helps to calculate the difference of the current movement position during each jump. So this is let me leave a comment here. Okay, so right now we've set it, we've just set it to 0, but as the jump is happening, it will be having the difference. So the values in here will be changing, particularly for the x coordinates. Okay, so once we have that, we can then come inside here in the update method. So remember, the update method is running in every frame. So this is going to be like at 60 frames per second by default, unless you've tweaked your your settings, but the default should be 60 frames per second. So this delta time value here is going to be, it's going to be a number that's going to be changing. It's going to be going from 1 to 60 and 1 to 60, just like that. So it's going to be updating. Okay, so we can use that to our advantage. So first things first. So first things first, we need to be able to measure the jump duration. So the simple formula that's given in the documentation is this. So being able to know how much time for a single jump. So it's like jump time is equal to the last jump time plus the frame interval. Okay, so now in our code, this is going to be realized based off of the variables that we've created. So this dot current jump time, which we initially set to 0 here. So this one here, and also on top here. So it's set to 0. Okay, and then we'll be adding on to it. So of course we can write the code as this dot current jump time plus, and then we can call the delta time. This value here from the update method, remember, this is the frame interval. Okay, the frame interval. So in this case, so this would work, but of course the documentation writes it in a nice, neat way. So just say plus equals delta time. So the plus equals just means that whatever value we have in delta time plus whatever value we have in the current jump time will be added, and that will become the new current jump time. Okay, so it's the same thing. So once that is done, you can then proceed within this same update method. sorry. So we need to be able to know if we're in a jump or if the jump is over. And so we write a simple if statement. So in the if statement, we just check if the current jump time is greater than the jump time. Okay, so this means that the jump has ended. So if the current jump time, the one that we've calculated here, is more than the jump time that's been allocated, then it means that the jump has ended. Otherwise, if it's less, then it means we are still jumping. Okay, so then we can define the logic inside here. So what we need to do is, if the jump has already ended, we pretty much just stop or make the start jump variable to false. We say that the jump isn't happening. So this dot start jump, so this was a boolean, so this becomes false. Okay, I think there's one more that I'm missing. Okay, so let me just add a comment here. Make sure the jump state says we are not jumping. Okay, I think there's one line that I missed here. So if the jump has ended, we also need to make sure that the character is where they are supposed to be at the end of the jump. Where have they been moved, or where have they been displaced? So to do that, we say node.setPosition, this.node.setPosition. So the set position method needs us to put in a vector 3. Okay, so we need to put the x, y, and the z index, so we can get the value from the variable target position. Okay, so this places the character where they should be at the end of a jump. Okay, so if the jump has ended, we move the position of the node, the character, the player, and then we set its position to the current position, okay, to the target position rather, and the target position was calculated in the jump step. Okay, so this is pretty much what we mean. So this is where this was being calculated. When we click the mouse and then the jump step function runs, here the value target position is the player's current position, okay, plus the value of the jump. So this becomes the target position. So this target position, in short, simply means where is the player right now, okay, plus are they jumping one step or two steps. So the player's current position plus 1 or plus 2 steps. Okay, so that's the idea here. So then whatever value we get, that will be the new position, and that's the position that we call the target position. And so we set the node to become to have that position. Then if we are in the middle of a jump, so we have to do what's called twinning. Twinning is making smooth, let's say smooth transitions between frames. So we don't want the player to more like, if the player, let's say, is here on this bracket, and when they jump they need to end up here, we don't want it disappearing and then reappearing here. We want it to smoothly transition to the next part. So we want the frames themselves to transition through, okay, so that it looks better. Okay. So to do this, firstly we need to get the position. So get the position of the player. So we can call this dot current position. This dot current position. So this one here, current position. So the current position, okay, this one here. Okay. Then once we have the player's position, okay, we can then call in the delta position variable, the one that we created earlier on, this one here. Okay, this one will know the difference. So it's got many values. In this case we just want the x1, not the y and not the z. Okay, so we just want the x because it's moving in the horizontal direction. So the delta x position is going to be this current jump speed multiplied by the delta time. Okay, so that we know the length of the frame to displace. Okay, this will be able to know if we're going to smoothly transition through, we need to be able to know how many frames we are accounting for, and so this is going to help us to know that value. Then lastly, or maybe not lastly, second last, we can then get the final value for what the new position will be. So say this dot current position will be an addition of the current position, okay, plus the difference, the delta position. Okay, so what are we doing here? So here we are setting the current position. We're setting the current position, this value here. Remember the first value in vec3.add. This is what the final value is going to be when we add the two vectors on the left, I mean on the right. So in short, it's this value plus this value equals this value here. So in short, what we're saying is the current position, let's say the current position is 1 and then the delta position is 2. So this is going to be 1 plus 2, and then the new current position is going to be 3. So this one here will be 3, which will update the value of current position. So we're setting the current position by adding, okay, the old current position plus the delta position. The delta position is the difference right, in the frames. Okay, then once that is done, we say this dot node dot set position. So we make sure that this has current position. Okay. Set the node to a new position. Okay. So that's really the script. So let me see if there's anything that we've left out. I think the only thing that we've not yet done is now writing for the events themselves, the click events. So the on mouse up event. So in the on mouse up function, we had said if it's a left click and if it's a right click, we get a 0 or a 2. So if it's a left click, we'll say this dot jump by step, the function, and then we'll supply how many steps, okay, that the function expects. Okay, so it will be either 1, or if it's a right click, jump by step, we'll give it a 2. Okay, so at this point, what this will now mean is if we right click, then we'll call jump by step and give it 2. So this one here, and so the value of step is 2. Since the value of step is 2, the size, okay, of the jump is going to be larger. So jump step is equal to 2 steps, 2 in this case, and so the jump speed will need to be faster because it's a bigger jump. So it's going to be 2 divided by the jump time. Okay, so that's how this is the steps are affecting the jump step. Okay, so if it's 1, then the speed will be a little bit it's going to be less speed because it's a smaller jump. If it's a bigger jump, the speed will be higher because the division will be by a larger step. Okay, and then this also affects the position because the target position where the player has to end up is going to be affected by the step itself. So if this is 2, then it means we are going to jump 2 blocks, or if it's 1, then we're going to jump 1 block. Okay, so we'll be taking the player's current position and then adding either 1 or 2 to make the target position where the player should stop, or where the jump should leave the player. So this is how this affects the jump by step function. So 1 step, target position will move by 1, or 2 steps, target position will be by 2. So that's what we mean there. So look through the code, just see if you've got any errors, or if you've missed out something. Remember to save, Control S. So these are the variables that I've created. Okay, you can also reference the documentation itself. If you're having trouble, then you can just copy the code from the documentation, and then that would also suffice. But writing is better because you get to practice. Okay, then you understand better. So that's the source code. Once the source code has been written, we need to embed it or add it to the player character. So this one here. So the player character, go on add component. Okay, add component, then we can go to custom script, then we'll see player controller, which is the script that we created here. so we need to add it. So it should be selected like that. I'll just control and save. Then once we do that, we need to also change the camera, because right now when we press on the camera, just double click on the camera, you'll see that this is the way the screen looks. Okay, this is how it would play out, but that's not what we want. We want it to be almost like it's in 2D. So we will change the position of the camera by the following values. So I'll click on camera, and then here we'll change the values. So firstly, its position will be 0, 0 by 30, 0, 0, 30. Okay. Is it 30? And I think it's 13 because I can't see anything. Okay, 0, 0, 13. Okay. The rotation has to be at 0. Okay. Then the color, this one here. So clear color, it's like 50, 50, and 50, 90 actually. And then this is 255, 255, 255. Yeah, so it looks like it's bluish. Okay, so that's the value of the color. Okay, so I know the tutorial says that the position of the camera has to be 0, 0, 0, but like I can't see anything here, and even when I run it, so here I've selected to preview in my editor, or preview in simulator rather. So when I run it like this, I can't see anything because the camera and the player are exactly on the same position. Okay, so I can't see anything. So they're exactly at the same position. So what I've noticed is here, okay, you can see the Z index, this blue line. So pulling it back further, okay, you'll then be able to see the player character there, the capsule. Okay, like that. Lastly, we can also just make one change in here. Let's see, the jump time is still set to 0, so set it to 0.1. You can play around with these values to find what you think plays well for you, but I'll leave it at 0.1 exactly like the way it's given in the actual documentation. Then we can also add the cube. So just add the 3D object, then we add the cube, so this one here, and then let's first we'll just drop it below. We'll make sure that it's below. We'll use it as a reference for how far the jump is happening. So let me just put it, let's say by -1. Okay, it's within the cube. Okay, so I'll drop it down a little bit further. Okay, let me see how it looks on the camera. Okay, then perhaps we can try running it. I just want to see how the jumps Okay, so let's see if we tried a left click. Okay, a right click. Okay, so right click is doing 2 jumps. Left click 1, right click 2. Okay, so that's fine for now. This is pretty much where we'll leave it for today. Like the video, subscribe, follow me on Twitter or any other place that I post videos or talk about game development. Thank you for watching.